This video file was recorded in Sabunji University during recitations for the CS204-Advanced programming course as it was given in the spring semester of 2017.
Now let's see another example with threads and mutexes. Let's see what kind of problems we have if we don't use mutexes and how they are solved with mutexes, but not always they are solved with mutexes. Our next example will be this one. Count 3k. Actually, it should be count 100k because we're going to count from 1 to 100 to 100,000. Let me see the output first, how it works, and we are going to go through the code line by line. Not this one. I'm not going to sleep. This one. I didn't get the output because of the system pause, sorry. Okay. So this is my output. Now pay attention, I'm going to run the same code again, and I'm going to have different outputs. So you see, I have for the counter value 100,000, but for the loop iteration count I have 96,000 and something. I'm going to run it again, and I'm going to have different, not because I'm doing something randomly, but because this is how it works. Again, I have here 100,000, more than 100,000, 100,215. I have 100,001 for the second variable. I'm running it again. Wow, this never happened when I tried it at home. I was very lucky at that time. Again, I'm getting different outputs. So let us see the code, and let's see what's happening. Maybe you can figure it out yourself. So, I'm including the threads, the mutexes. The chrono is the chronometer. This is for sleep, wait, something like that. It's not very important right now, but you're going to need it also. I'm not going to go through details with this stuff. Maybe I'll explain it later. I have two integer variables, counter and CTR. And the maximum is 100. Those are global variables. Of course, I have the mutex here. What I'm trying to show, I have another function, or a function, which is called count. And this is what the count is doing. While the counter is smaller than the maximum, I increment both of them. Actually, I should iterate it how many times? 100,000 times. Okay, because maximum is 100,000. But as you saw, sometimes I got greater values, sometimes I got smaller values, blah, blah, blah. And we will see why. Because I'm creating 6 threads here, and I'm calling them simultaneously to run this program here. But pay attention. Counter and CTR are global variables, meaning all of the threads, 6 threads that I'm going to create in main, can see that. So they are global. If one thread makes a change at one of those global variables, the others can see it. So what I'm trying to do, all of those 6 threads, and they're going to call this function, and this function increments counter and CTR, are going to work on them in parallel manner. Sometimes one thread, another one, but in a sense, all of them you should expect, when they combined, add it up, they should increment those guys by 100,000 this one, 100,000 this one. But as you saw, the output was not like that. So let us see what's the problem here. In main, so I create those threads, and all of those threads, so I am creating an array of threads. I can do that. I can create an array of mutexes. It's not a problem. And all of those threads should run this function count. As you see, the count doesn't have any parameters. That's why the only parameter that the threads will have is the name of the function itself. It's given in this way. This is called a delegate, and you don't know what is this. I don't know whether you're going to learn it here in Sabunji maybe. It's an advanced topic, but kind of this guy references the function, but it's not a common reference that we have been used with, because count is a function. And this guy is referencing the same function, in a sense. This is called to delegate. Just, learn it by heart. Remember it, that the count goes in the name of the function. If we have parameters, we put that. If we don't have, this is it. But it should have at least one parameter, which is the name of the function. Then we join all of those threads that we created as an array. We join them with the main thread, meaning they work toward the same goal. They are part of the same process. They can see the same global variables. And we let them execute. I forgot to tell you, the main function, the main thread, waits those guys to finish, and when they finish, it prints this stuff, okay? So like the father gives priority to their children, okay? Because if the main thread finishes, we will have return 0, and when we have return 0, everything that is related to this program is going to be erased, but those threads still exist there, and they're trying to access something that is erased, and the program is going to be crashed. Okay? That's why the main waits for the other, the father thread. At the end, those global variables, you remember CTR and counter, we print them, and we should expect 100,000 for both of them, because they are both incremented here. From counter, which are both of them 0, to maximum. Maximum is 100,000. We increment them, so you would expect we will have 100,000 here, but it's not the case. Can you tell me why? I'll start explaining, but you can figure it out. Try to figure it out. So this is the counter variable. This is the CTR. And here I have the threads, the array of threads. From 0 to 5. I think I had 6 threads. Yes. From 0 to 5. And those, and the maximum, of course, which I'm not working, I'm not changing it. Initially, those guys are 0. And those threads, all of them, can see the count and the CTR, which are global parameters. So why do I have this problem? Why sometimes counter is greater than CTR, CTR is greater than counter? And also pay attention. You see, the counter value is approximately always 100,000, which makes sense. Why? Because I iterate this while loop up until counter is smaller than maximum. So counter shouldn't be greater than 100,000. Because if it's 99,999, I'm incrementing it, it's becoming 100,000. Next time, this condition will not hold, and I'm going outside from the while loop. It will not be executed anymore. Why do I have this stuff? Can you tell me? So you saw sometimes counter, it's okay. I'm telling you why the counter is always approximately 100,000. You might have it 100,001, and I'm going to explain it later on. But you see the count, the CTR, changes its value. Sometimes greater than that. Sometimes it's, like in this case, it's smaller than 100,000. Sometimes it's the same. Although if we had one thread, they should have had the same value. So can you come up with the solution?
Can you show the function?
So this is the function again. If we had one thread, this guy, we start from 0 for counter CTR. So this is 0, 0 initially. Okay? We iterate this guy for maximum times. So the value of this guy and this guy should be 0, the same. Because they both start with 0. And whenever we enter the while loop, we both increment them by 1. So when the program finishes, the value should be 1. If we had only one thread, for sure the value would have been 1. But not in this case. I told you why the counter is always 100,000. Because if it's greater than 100,000, this while loop is going to be false, and we are going outside. Okay? So it can be. But this guy is sometimes greater and smaller. An idea? Yes, Omar?
CT CTR++ is actually 3 operations, I think. It first reads the value of CTR,
Yes.
and it adds 1,
And then puts it.
So when two threads do this at the same time, sometimes it reads the old value of CTR before the other thread like rewrites it. So like when they both try to add it, like it only adds by 1.
Exactly. This is it. Actually, this is something that we showed during the last class. So this is the problem when if you are programming in assembler, it's easy. Because the computer doesn't understand counter plus plus. Computer understands ones and zeros. Now this counter plus plus is done in terms of assembly languages in another way. How it's done? Very roughly. It takes the value. So all of the threads do this stuff. 1 takes, let me write it, takes, sometimes this is called fetches, takes the value. I'm talking about CTR++ or counter plus plus. 2, increments that value, increments the value. 3, puts the value back. Meaning, I'm taking the counter, incremented it 1, and then I put it here. Okay, this is how it works. Now let's assume that I have 2 threads working simultaneously. And let's say that the value of the counter is 5, and the CTR is 5. Let's assume it. Now, you see the while loop here. 1 thread is being executed out of those 6. And we have counter plus plus. So this is the case A1. Okay, I'm going to see it and let's see how did we get that case. The counter plus plus, let's say this thread is scheduled, this one. It increments the thread using those 3 sub-instructions. And when it's finished, we have 6 here. Okay? Then it goes, and then another thread is scheduled, let's say this one. And this makes the thread 7. We are still at this counter, okay? Now both those threads should go to the CTR++, and they're not interrupted when doing those 3 steps. Now here are both of them, 0 and 1, let's say only they are running for the time being. Now the thread 0 fetches 5, okay, it's here. So this is thread 0 with blue. This is thread 1 with green. So it fetches the value for the counter, CTR, 5. And I know it's 5 here. I'm writing 5. It increments it. It makes it 6. But just before it should put it back, the operating system says, okay, it's enough for you. It's the time of the other thread to run. Now this thread also is doing the same thing. It sees the counter 5, yes. So it puts it here, 5. Increments it, it makes it 6. And puts the value back, so 6 is put here. When this is done, the operating system says, okay, it's enough. It's the turn of the blue one. And where did the blue one stop? Here. It remembers when the blue one stopped. That's why it puts the value back. And I erase the 6 and I put 6. So I didn't stop those 3 steps when I was incrementing the counter. Okay, for those 2, it was 5 initially, if you remember. Both thread 0 and thread 1 incremented it, so it became 7. But when I was incrementing the CTR, it stopped. Somehow the scheduling overlapped. And the green thread, incremented it, but it was overwritten by the blue thread. That's why I have 7 and 6, although this is one iteration of the while loop. At the end of the while loop, what do I have? I have that the counter is greater than CTR. Okay? In this particular iteration. Can we have the case when the counter, this guy, is smaller than CTR? Of course we can have. At the time when I'm trying to increment the counter, they overlap. So the old value, one of them puts the value, then it's overwritten. But when I'm trying to increment the CTR, okay, I am not interrupted, and I increment it. So I put 6, then I put 7, this is it. Basically, they switched. It's the same case, but now CTR becomes counter, counter becomes CTR. Can it happen that the values can be the same? Yes. How can it be the case? Well, it is the case when I'm not interrupted at all. I increment counter, then I increment CTR. One thread is doing it without interruption for both of them. Another one is doing the same thing. Or it might happen that this thread writes this guy, it's interrupted, so I have 6 again. Both of them are interrupted, okay? Do you understand what I'm talking? It's like this. Are we okay with those two cases, previous cases? Yes or no? Yes. Now let's go with the other case. A3A, I might say. I know it's getting hard, but it's not hard as you think. I increment the counter plus plus, CTR plus plus without interruption. Counter plus plus, CTR plus plus without interruption. So initially the value was 5. So I increment 5 and it's 6. The blue one is doing this stuff now. From 5 it's 6, no interruption. The blue one again, from 5 it's 6, no interruption. Now it's the turn of the green one, and it's doing the same thing without interruption. So it was 5, 5, now it's 7, 7. So this is the case when the counter is equal to CTR. Another case, A3B, is the following. Let's assume that the values are 5 again. So the blue one is running for the counter plus plus, and it says, okay, I'm fetching 5. I want to increment it 6, but it stopped here just before putting its value. And this guy now is taking the turn and says, okay, I'm fetching 5, I'm putting 6, I'm putting the 6 here. Now it's the turn of this guy, which was stopped just before putting the 6. So the blue one puts the 6. And the blue one continues with the CTR. And again, I'm taking from the CTR 5, I'm incrementing it being 6. And now just before I'm putting it here, it stopped. The green one takes turn. And again, it takes 5, increments it to 6, put 6 here. Okay, it stopped now. It's the turn of this guy. It puts the 6 back to where it was. Okay? So they were both interrupted, overlapped, but the value is the same. This is counter equal to what? CTR. Okay? Is this clear? No interruption at all. I increment this one, then this one, then the other one takes turn. Or I override this one, then I override that one. In that case, when I incremented both of them, I had 7, 7 here. But when the incrementations overlapped, I am having 6, 6. I know it's a kind of advanced topic, but this is how it works. And computers work with threads. That's why you remember we saw 1,000, 2,000 threads running out. So this is the case A, when the value of the counter and the CTR is not usually the same. It might be the same, but if I'm lucky. It might be the same when in some of the iterations the counter value is greater than the CTR. In another one the counter value is smaller than CTR. So kind of they eliminate each other. So they come to the middle when the value is the same. But usually it is a greater or smaller. But the counter cannot be greater than 1,000 because we are checking always when we go inside the loop, we're checking whether it's smaller than maximum. However, sometimes you might get 1,001. Why? for the counter.
Two threads incrementing at the same time.
We're not incrementing. Now we are checking this while loop. So just imagine. This is again, the green thread. This is 99,999. Is that smaller than 100,000? Yes. Okay. So this guy checks this stuff, enters here, but just before incrementing the counter, it stops. This guy also checks. Is 99,999 smaller than 100,000? Yes. It also goes inside. This guy increments the counter. This guy also increments the counter. That's why sometimes we have 100,001. Okay. I don't think I'm going to be okay. So 100,000. Let me get 100,001. No, I'm not getting it. I'm not getting it because it rarely happens, really. But it happens. You can check the videos. I think it happened when I was explaining the code. Okay, it just happened now. 100,001. Okay. So this is an obvious problem. How are we going to solve that? Mutex. That's why usually if we have two shared variables, we should have two mutexes, and this is the better way to do things. But in this case, you see what we are doing. We are either incrementing counter plus plus or the CTR plus plus. Okay, what does that mean? That means that either you are here or you are here. You cannot be in another place because you increment in those two. That's why if one thread is here, the other one can work here. For sure. Okay? For this reason, we don't need two mutexes. We need only one. Let's say we increment which one? When we increment the CTR, we put a lock here, and the others can increment the counter. But it's like this. When someone increments the counter, and it locks the CTR, and the other one increments the counter also. But when it tries to get here, it stops here. It doesn't go further. If we have 6 threads, all of them stop here. Only when the first thread is going to release the lock, one of them, the one that is lucky to be scheduled at that particular time when the lock is released, will enter for this one. Okay? So in this way, we are sure that at a particular time, only one thread will be working in both CTR and counter plus plus. Let me run the program, and we'll see that the result is the same, approximately. 100,000, 100,000. Okay? I'm not going to engage in details because it's hard to digest. If we add some sleeping time, okay, so this is used from the chrono class. This gives like 1 microsecond. You can use here milliseconds, seconds, minutes, or whatever. I'm making the thread to sleep. Sleep means I'm not doing anything. If it's my turn to work, I'm not going to do anything. I'm going to stay idle. It's going to get a bit more complicated, but I'm not going to be engaged in details. So we have A, B, C cases, and sub-cases and sub-sub-cases. We saw for the A, we saw all of them for the A case. For the B case, it's usually counter is equal to CTR. Usually it's like this. Sometimes you might get some other result, but I don't want to engage in more details. So this is threats. Yes, they're beneficial, but they're challenging because it's really hard to anticipate what is going to happen, and you get very weird outputs. But jobs are very hard without threats. Yes?
Why don't we put the lock before the counter?
Yeah, you can do that, but this is what I'm trying to say. Another problem is the following. When you're incrementing the counter and another one wants to increment the CTR, you shouldn't be an obstacle for him. Okay? That's why we're not putting it in the beginning. Because if you put it in the beginning, initially you increment the counter, but another thread wants to increment the CTR. And you are preventing him to do so. And this will result in lower performances. So this is one way of doing mutual exclusion I was talking about. If you are not working in a critical region, you should let others to work on it. Okay? So this is it. Any question? No question. Let's go with another example. Now we have seen two functions. One function actually. Previously you remember it was which one? So this is the count. All of the threads call one function. But now we are going to see threads calling two functions. I'm going to remove this guy. The next example is called increment decrement. Okay. Let me run the program first. I hope I have the system pause here. I have it. Let me see the output. This is what I'm trying to do. What I have here is the following. I have 4 threads. I have a shared variable. 2 of the threads decrement the value of that variable, and 2 other threads increment it. And you can see which one is doing which. So we have from 0 to 3. And the schedule is not, it's 3, 2, 1, 0, 3, 1. So you cannot figure out. If I run it again, I'll have another schedule of threads. But you know that, for instance, thread 0 always incremented, and thread 1 always incremented. But thread 2 and 3 decremented by a random value from 1 to 7, or from 1 to 6, something like that. Okay? And increment the same shared global variable. So I start, I think, initially with 0, and this is what I get in the end. If I run it again, not only that the schedule of a thread will be different, result will be different also. I'm ending with 5. Okay? So I'm going to erase this stuff now. I'm going to leave the stuff about mutexes and threads. Now let's see how did I do this stuff. How did I get this output? Now, I'm sharing what? I'm sharing a global variable, which is called global count. So this is my global count here. But hey, we had the problem with cout also, which was also shared. So you can assume that cout is a kind of, okay, a class. And here we have the buffer. And you remember the example from the last class when we get the garbled cout output, okay? We don't want to have it again, okay? That's why I wrote it here. And for this reason, I should have maybe, okay, this is not a good way of doing things, I think, but okay. I have file mutex. So this is mutex for locking this global count. So no 2 threads will work at the same region simultaneously. And as we are going to see, I'm going to have 4 threads which are all working in this region. Let's only the mutex to do some mutual exclusion between them. I have another variable called decrement threads. Its value is 2. Increment threads, its value is 2. I have the iterations. We have 4 iterations. This is an array of 4 elements. And their corresponding values are 5, 5, 5, 5. I have a function called random range. And if you're going to use it for your homework also, you shouldn't use the random generator class we have seen in CS201, because it's not working properly with threads. If you want to use random number generator, this is how you do it. It generates a number between minimum and maximum. I think in our case it's between 1 and 7. Okay, so this is random number generator. You should also include the corresponding classes. I'm not going to engage into details. You can just copy paste this code and use it. Okay. the important stuff is the increment function. The increment function, as you can see, takes an integer as a parameter called thread IDX. This is the ID of the thread. We iterate from 0 to iteration thread IX. What will be its value? You remember this was an array iterations here. It had increment thread plus decrement thread, so it's had 4 elements. And the corresponding values of that array, you have 5, 5, 5, 5. Basically, we iterate this stuff by 5 times. What do we do for that stuff? We sleep for 2 seconds. Then we go to the critical region. There's some mistake here. We are going to solve it together. When we go to the critical region, that is the region that we share with others. So we lock it, and when we lock it, when this mutex is locked, that means that we can increment the global count here and also print corresponding message. So first, we take a random number between 1 and 5. We increment the global count with a random number. It might, okay, we increment it. And we print cout, incremented thread, blah, 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 variable was. And we increment the iteration, but say the iteration is part of each of those threads. So those are threads. And this iteration is a local iteration for all of the threads. But those guys, cout and global count, are not. Here, when we don't want to interfere with this global, so this guy is just incrementing, the other one is decrementing, is overriding the values. When I want to increment the global count or decrement it, I just increment it, print the message, this is all. But this is the problem that your friend asked previously. Namely, I can increment the global count, but I'm still not printing anything. And I'm preventing another thread that has already incremented this stuff to print its message. So maybe we should have here 2 mutexes. Okay? One mutex for the global count, and another one for the file. Because if I'm working over here with one thread, the other thread is free to work with the cout. Okay? I shouldn't prevent it, but I'm preventing it. Okay? It's like a kind of selfish way of doing things. But, so what we should do, I should put here, just before incrementing, after incrementing, file mutex, I could declare another mutex called cout mutex. And I put cout mutex lock, cout mutex unlock. Iteration plus plus is not a globally shared variable. It's inside of the thread. That's why I put it here. So I don't have to lock anything about that. And this is how it works. Okay, so it would have been better if we would have done this with 2 locks, with 2 mutexes. So this is the increment function. The decrement function is doing pretty much the same. But you remember here we have plus equal, meaning we increment. But here we have minus equal. We decrement it. Otherwise, everything is the same. Here we introduce this one. We are sleeping for 100 milliseconds, which is 1 second. Just to simulate that a thread is being clayed. Because sometimes you're going to write web applications, and the latency might be a few hundred milliseconds. Just to send a request and get it. In order to simulate it, you can do something like this. So in main, we declare an array of threads. Oh, this is that. So this is that array of 4 threads. And we start from 0 to 4, meaning 0 to 3. For threads that are smaller than 2, meaning 0 and 1, increment. So those guys increment. Those 2 increment. The other 2 decrement. Okay? So if it's not small, if it's smaller than 2, meaning 0 and 1, the thread is calling the increment function. The ID of the thread is I, from 0 to 3. Otherwise, the thread is calling the decrement function. The ID of the thread is I, meaning it's going to be 2 and 3. This is it. We should join them now. So from 0 to 4, we join all of the threads, and they call the corresponding increment and decrement by random number from 1 to 5, and this is how we get the output. Did you get this stuff? Let me run it again. Pay attention, this is the ID that we generate, we give them to them, but the operating systems give another ID to them. You can take it with get ID. It's usually a 4-digit decimal number. So this is how we got it. Okay? Usually we don't get 0. Any question? If you don't have a question, then I'm going to relate this one with your homework. Namely, you should do very similar stuff in your homework. You have a bank account. In that bank account, I think that multiple people can increment it, only one can decrement it, meaning multiple people can send money to your bank account, but only you can withdraw them. But you're going to use that using threads. So I think you have 4 decrementers, 4 incrementers, and only 1 decrementer. Or maybe vice versa, something like that. So you can use this example as a backbone for your homework, and it's going to be kind of even trivial, I would say. Easy to do. Let me show you what you should do. So, and I forgot to tell you that the incrementation is done by 1. So, let me go with the sample rounds. You have a txt file. In that txt file, you have only 1 integer. And usually it's 0. If you don't have this a.txt, you should create it and put 0 there. Then what do you give? Maximum waiting times between withdrawal transaction. 3 and 3. Meaning that if I withdraw money now, what is going to be the next maximum time that I'm going to withdraw for the next time? It's 3 seconds. Minimum time, if I withdraw money now, the earliest I can withdraw again is after 1 second. The latest I can withdraw again is after 3 seconds. Okay? So this is 1. The total number of withdrawal transactions is 4. The total number of deposit transactions is 10. Meaning that I'm going to, between those intervals 1 and 3, I'm going to withdraw 4 times, and I'm going to deposit 10 times with a thread. The simulation starts at this time, and you see 1 Turkish lira has been deposited. The balance is 1. Initially it was 0. I deposited once, it won. It is now 1. You remember, I'm going to deposit 10 times. Now let's see how many deposit transactions do I have. So this is 1 here, deposited. This is 2. This is 3. This is 4, 5, 6, 7, 8, 9, 10. And this is it. I'm finished. How many withdrawals do I have? What do you think? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why do I have 12? Because I'm going to have 1 thread that is going to deposit and 3 threads that are going to increment, withdraw. Because I have 3 threads, all of them withdraw 4 times, so that means that I have 12 withdrawals. Let me tell you another sample run. So this is okay. Let's go here. So the time between withdrawals is at least 1 second, at most 3 seconds. So let me see here with the withdrawals. I have thread 2 withdrawing at 21:37.
Deposit and withdrawal have different minimum times. So it's 3, or it's always 3 and it's always 1.
Yes, but this is what I'm trying to say. So thread 2 deposited at 21:37. Okay, now let's say next time when withdrew from at this time 21:37. Now let's see the next time when it's going to withdraw. Thread 2 again. This is at 40. You see we have 3 seconds in between, the maximum. Let's see this next time. We have 43. from 40 to 43. And let's see the next time it's 46. Okay, so actually the minimum and maximum time of waiting for withdrawal is 3, meaning exactly 3. But the maximum and minimum time between deposit is 1, always 1. That's why if you see, okay, so this is for depositing minimum maximum, this is for withdrawal, minimum maximum, deposit minimum maximum. So you see this guy deposited at 35, then at 36, then 37, 38, 39. 1 second, because the minimum maximum is the same. The minimum maximum can be different, as it is the case here. So for withdrawal, you should wait at least 1 second, at most 2 seconds. For deposit, you should wait at least 3 seconds, at most 4 seconds. 4, 10, meaning we have 12 withdrawals, 10 deposits. Okay, and you're going to see the output. Always when you run the code, you're going to get different outputs, but those boundaries are preserved. Okay, this is your homework. I think it's straightforward. Here we had in our example 2 threads, 2 incrementing, 2 decrementing. In your case, you will have again 4 threads, 3 decrementing, 1 incrementing. This is it. You will have again 2 functions, increment and decrement. You can do it, I think, in a couple of hours. Any question? I don't expect to understand 100% everything. If you understand what I'm talking about, if you understand me right now, this is it. Because when you're going to watch the videos or go through the codes again or the document, you will see what I'm talking about. You need time to digest it, especially with threads, because this is not a common way of thinking and reasoning. You're not used in this way of thinking. Okay, see you in 2 or 3 minutes.